Hi students, today we are going to discuss the principle, working and construction of an electric motor. Then what do you mean by an electric motor? An electric motor is a device that converts electrical energy into mechanical energy. It is used as a main component of electric motors, electric fans, mixers, grinders, refrigerators, etc. Then let's see the construction and working of an electric motor. So as I said before, here a figure shows the setup of an electric motor. The main parts of an electric motor is shown in this figure. So as I said, the principle of electric motor is converting electrical energy into mechanical energy. As we can see here, two permanent magnets are there. Okay, two permanent magnets whose north pole and south pole, unlike poles, are fixed in a position. Then next, a rectangular coil with a good conductor of electricity is placed in between the two magnets, and this coil consists of a large number of turns, and which is called as a armature, and this armature is placed in between the two magnets, and the armature is then the two terminals of this armature, that means the coil is connected to a carbon brush. The one side, the another side, another carbon brush. So the side AB is terminal is connected to the X carbon brush X, and CD is connected to the carbon brush Y. And also we can see a axle here, an axle or a shaft which is passing throughout, almost passing through the center of this armature or the rectangular coil. Two split strings P and Q are connected in the axle or the shaft. The inside of these two rings are insulated and attached to the axle. They are attached to the shaft, and this shaft is attached in a point O in such a way that the shaft or axle can rotate freely. Then when the shaft rotates, what will happen? This rectangular coil or armature also will move. These two ends of this armature is connected to the carbon brushes X and Y, and this carbon brush, then from this carbon brush, then it is connected to a positive terminal of the battery in this side, and Y is connected to the negative terminal of the battery through a key. Then here this setup, that means including the carbon brush and the split rings. Split rings are, what are split rings? Split rings are two half rings. Okay, half rings are connected to the axle. Then this setup is called as a commutator. Then what do you mean by commutator? Commutator is actually commutate the electric current and the circuit. Okay, it passes, it allows the electric current passes, and how it is allowing electric current passes through it, and we'll see later. The electrical energy from the battery is passes to the brush, and then brush to the ring, and then it goes to the armature. Now this is the construction of an electric motor. So here there is a large number of turns in this armature. Okay, as we know that when the electric current passes through this armature or a solenoid or a coil, it produces the magnetic field around it. And the magnetic field produced by the coil then is under the influence of a magnetic field produced by the another magnet there. So as we have already discussed that, and when these two magnetic fields are produced there, then a force will act on this conductor, and that force will make the coil rotate. Okay, then, and when this coil rotates, this shaft will rotate, and this shaft is then connected to a device, or like a mixer or grinder or refrigerator, and then when the shaft rotates, and the equipment or the device also will work due to the movement of this shaft. This is how this motor converts electrical energy into mechanical energy. And now here, and what is the importance of this commutator system here? So we know that the electrical energy that we allow to pass through the entire system through this commutator split rings. So if these two terminals are connected here, if it is directly connected to the axle, so what will happen? And this, when the axle rotates, so these wires connected to the axle will get strangled, or it may get twisted. So when it is get twisted, as it rotates, it will get more twisted, and finally it will break and the circuit will disconnect. In order to avoid this commutator system is made with the help of two carbon brushes and the split rings. And when the axle rotates, the split rings attached to it also will rotate, and when it rotates, these split rings will alternatively come into contact with the carbon brushes on the both sides. Then when they are come in contact with the carbon brushes, then the circuit will, electric current will flow through the circuit, and then it rotates again further. So what happens? Then the connection between these half split rings and carbon brushes will breaks. So when the connection goes or breaks, then there is no electric current will pass through it, then there is no magnetic field, then there is no force produced on the current carrying conductor. So that the entire circuit will be disconnected. And this is how this twisting or strangling of wire is avoided in this case. And now let us see how does it works. This rectangular coil is perpendicular to the magnetic field. When the key is on, so the electric current from the positive terminal flows to the carbon brush X, and when this carbon brush X is connected to or come in contact with the split ring P, so then the electric current will flow from A to B. When it flows from A to B and then goes to C, and now the electric current is coming back from C to D and enters to the carbon brush Y, and to the, when the carbon brush Y is come in contact with the split ring Q, then the circuit will complete. Okay, so let the goes to the carbon brush and then contact with the brush split ring P, and here from this side the electric current flows from C to D and enters to the carbon brushes, and when brush come in contact with the split ring, then the circuit will be completed. So when this circuit is completed like this, so what will happen? And there will be a magnetic field produced by the each turn of this circular coil, rectangular coil, and this magnetic field produced by the rectangular coil is under the influence of another magnetic field produced by the magnets, two permanent magnets here. So this will lead to a setup of a force or torque on the coil, and this torque makes the armature to move or to rotate, and when it rotates, what happens? This when we apply the Fleming's left hand rule, and we can easily find out the direction of the electric current and the direction of the magnetic field, and now the direction of the motion. And here when the electric current flows from A to B and C to D, then the motion is in the downward direction. So when the motion, the force acting on the coil in the downward direction, so what will happen? The coil will, the side A, B will go down, so that the side C, D will go up. So when it go, one side will go up and the another side will go down. It rotates 90 degree. As it rotates 90 degree, then what will happen? The connection between the split rings and the carbon brushes will break. So when it breaks the connection, so what happens? The supply will be cut off. Then there is no magnetic field produced by the coil. But that means there is no magnetic field, then there is no force acting on the rectangular coil. But even though the circuit is disconnected, there is no force acting on the rectangular coil, but still then as it moves 90 degree, and due to this momentum, the coil will move further and to reach again perpendicular to the magnetic field here. So that means now what will happen? This side AB will come this side and CD will come this side. So that means the direction of the electric current will be get reversed. So now the rectangular coil is completely rotated 180 degree. Then when it rotates 180 degree, then the side CD will come to this side and AB will go this side. Now if you write, this is side DC and this side will be AB. And now here the direction of electric current is D to C and here B to C. So at this position, again these carbon brushes will come in contact with the split rings, so the electric current will flow through the circuit. Again it will rotate 90 degree due to the torque produced by the magnetic field produced by permanent magnets. Okay, then and when it rotates 90 degree, this circuit will disconnect. Again there is no force will act on the rectangular coil. But due to the momentum, it will rotate again 90 degree. That means the side AB will come back to its previous position, CD will reach its previous position. And this will continuously take place, connecting, disconnecting, connecting, disconnecting, so that the torque will produce and again it will terminate. Torque will produce again, the torque will terminate. So that it makes this axle to rotate continuously and with a speed, and this makes the shaft to rotate continuously, and the device which is connected to the shaft also works continuously. And this is how an electric motor changes or converts electrical energy into mechanical energy. I hope you understand. Thank you.